Hi everybody, welcome back. Today's learning target is I can use the distributive property to simplify a variable expression. So before we start talking about this, there's a few very important words that you need to know. The first of these is term, and a term is each part that's added together in a variable expression. Another important word that you'll want to know is the word coefficient, and that's the number that's in front of the variable. So for example, in the expression 3x minus 4, my terms, I have two of them because there's two things being added up here. So 3x is my first term and negative 4 is my next term. And then this 3 in front of the x is a coefficient. So these are words you'll want to be familiar with because we'll use them over and over again. Like terms are special. These are terms that have the same variable or the same letter, and they also have the same exponent. So some examples, 3 and negative 5. These are both constants, so those are like terms. 2x and 6x. Again, they both have x's, and they both have an exponent of 1. Let's do one more. 4y squared and 8y squared. So you'll notice both of these have y's, and they also both have an exponent of 2. Okay, some non-examples. 3 and 3x. Those are not like terms because one of them is just a constant and one of them is an x. 5x squared and negative 4x. You might be thinking, hey, both x's, we're great, but 5x squared has an exponent of 2 and negative 4x is an exponent of 1. So those aren't like terms. And 3x and 2y. Here we have different letters, so those are not like terms. And one more. Let's say we have 5x and 6xy. Well, you might be thinking, hey, they both have an x. However, because this xy is there and they're touching each other, those are not going to be like terms either. So you've got to have the same letter, you've got to have the same exponent. When you put terms together that are like terms, this is called combining like terms. When you combine like terms, your goal is to get only one of each like term. So only one constant, only one x, only one x squared, only one y, etc., etc. And you'll also hear this called simplifying an expression. Okay, so let's do some problems. We're going to simplify completely by combining like terms. And the first one we're going to do is 3x plus 4. So I got to look for the like terms. And so 3x, I'm looking and I don't see any other x's. Okay, and then here's our constant, our plus 4. And I don't see any other constants. So this one actually we're not able to combine. It's just going to be 3x plus 4. Okay, let's do another one. 9x minus 8. So same thing. I have 9x and I don't see any other x's. Okay, negative 8, here's a constant. And I don't see any other constants. So this one's actually just like the one above. It's going to be 9x minus 8. One thing you got to remember is only combine like terms. This is one of the most frustrating, most basic, and most common mistakes algebra students make, not only in problems early in the year, but in some of the more complicated problems later in the year. So one thing you have to remember is you can only combine like terms. 3x plus 4, you might be tempted to say that's 7x. That's wrong. Don't do it. 9x minus 8, hey, that's just x. Absolutely not. Don't do it. Learn this right now, and I promise you, you'll save a lot of frustration later in the year, and in later years as you get older as well. Only combine like terms. Otherwise, leave them separated. Okay, a distributive property. This is something cool that comes up. And what happens for the distributive property, for all terms a, b, and c, a times the quantity b plus c equals the quantity b plus c times a equals ab plus ac. Now you might be freaking out with all these letters, but we'll do examples with numbers very shortly, so don't worry about it. The main concept with this is if you have a number or a letter and it's touching parentheses and there are things being added or subtracted in the parentheses, you're going to multiply the outside number that's touching those parentheses to both of the terms that are inside. And it doesn't matter whether the number or the variable that's touching the parentheses comes first or it comes after the parentheses. So I can take this a and I can multiply it to both the b and the c and then add them up. And the same thing here. The number of variable expressions touching the parentheses is multiplied by every term inside the parentheses. So I'm not just multiplying the a by the b, I have to multiply the a by both the b and the c. So let's do a problem for this. We're going to use a distributive property to rewrite the expression without parentheses. Then we'll simplify by combining like terms. So I have 3 times the quantity 4x minus 5. And here's my number touching parentheses. So I have to take the 3, I have to multiply it to the 4x, and I have to multiply it to the negative 5. So I have 3 times 4x, and I'm going to add it to 3 times negative 5. And now a lot of you will probably skip this step in the middle, but if you need to, make sure you write it so that you don't forget that the 3 gets multiplied to both of those terms, and then I end up with 12x minus 15. And remember, like we said before, the 12x and the negative 15, they're not like terms, so don't combine them. Leave them separated as 12x minus 15. Okay, one more example. I have the quantity negative 8 plus 2x times 5. And so same thing. Negative 8 is going to be multiplied by 5, and 2x is also going to be multiplied by 5. So I have negative 8 times 5, and I'm going to add that with 2x times 5. And so my final expression is negative 40 plus 10x. Okay, so there's the first part of our video about simplifying expressions, the distributive property, and in our next video we'll get some more complicated examples with more steps.